Hi, welcome back to Mind and Maths with Amina. Today we're going to learn about static expectations. This is one of the simplest ways economists think about how people form expectations about the future. It basically means that whatever is true today, we assume will also be true tomorrow. So there's no forecasting, we don't have any prediction model here. It's just a straightforward copy paste of the present into the future. We'll start with the idea, then apply it in the goods market, derive equilibrium income, and solve a numeric example so the whole concept becomes clear and intuitive. So I've written down the main definition of static expectation, which is that people expect that the value of an economic variable next period will be equal to the current value of this variable. So mathematically, we can write this as follows. We can write that we expect the value of the variable in future period to be the same as it is now. Okay, so let's suppose we have we're examining the goods market with static expectations, and suppose the model is given as follows: yt is equals to ct plus it plus gt, and suppose the consumption function is a plus b y e, so expected income in the next period. Let's assume that investment is basically equals to an I, and government spending is equals to a G, so they're just autonomously set and they're constant. Because we have static expectations, we're going to assume that whatever is true today is assumed to be true tomorrow. Okay, so what we're going to write, plug into our model, is that the value of the expected value of the variable in the next time period is simply the value that it is right now. So therefore, this consumption function becomes equals to just a yt. Now when we put all this information back into the model, we get the following. We get yt is equals to a plus b yt plus I plus g. So yt is equals to a plus I plus g over a 1 minus a b. And we can get multipliers over here by we can get the fiscal policy multiplier by taking the derivative with respect to g, which is basically 1 over a 1 minus b. And you can also see the impact in a change in investment will have on output, which is actually going to be the same. Okay, so this is the long run, or basically the equilibrium level of output. And diagrammatically, we can make this diagram that in static expectation, the value of output remains at, let's just call it y bar. So where y bar is equals to an a plus I plus g over a 1 minus a b. Okay, let's just suppose we have a one-time shock. What happens in that case? So if we have a one-time shock, then it means that we had a temporary shock, so there was a sudden jump here, and then our model came back to the original, the value of y bar came back to the initial, so it dropped down over time and it came back to the original value. However, if the shock was permanent, then it's going to settle at a higher level of output. So this is what the trajectory should look like if we have a permanent shock, and this is what it's going to look like if it's transitory. So remember, the persistence of the shock actually depends on the value of rho in the shock. When we write the shock term as an AR1 process, as ut is equals to rho ut minus 1 plus a white noise et, which is normally distributed, identically normally distributed with 0 mean and 1 variance. So it's the standard normal. Whenever the value of rho is equals to 1, we have a permanent shock. So what this means is that the shock never fades. New level becomes the new baseline. However, if the value of rho is equals to 0, then this is just a one-time shock. So this means that the shock only lasts one period and immediately disappears. So it's just going to, like, for instance, go from here, one value here, and then fall back quite instantly. Okay. And if the value is between 1 and 0, then this is kind of like a transitory or like a decaying shock. So in this case, the shock fades gradually and over time. So basically, the value of rho measures the memory of the economy. It measures the memory of the economy. So if the value of rho is high, the shock is remembered for longer. And if the value of rho is low, the shock fades quickly. So in our model, I didn't actually, let's suppose there's a shock in, let's suppose we have the same model. So the same model. But this time there's a shock term which enters the consumption function. We solve it since we're still doing static expectations. Therefore, the expected value of output in the next period is still going to be equals to yt, same as today. And therefore, when we solve the model just like before, we're just going to end up with an extra shock term there. So solve as usual method, and you end up with a static equilibrium output, which will be equals to A plus I plus G plus mu T over a 1 minus P. So basically what happens here is that y is basically equals to y bar, which was the long run static equilibrium output, and then there's a bit of shock, which actually, let's just use another term, let's just write it vt, where the shock is basically mu t over a 1 minus v. So what this shows is that you can imagine that the long run equilibrium is at y bar, just like the static model predicts, and the only deviation in yt is due to the error term. So the only deviation in yt occurs due to the shock term. So for instance, we could have an output which is going up, down, up, down, up, down, but that's simply because of the shock. For instance, we have a positive shock here, we have a negative shock here. But if there's no shock, then output would actually stay constant or basically static at the value y bar. So I think that brings an end to this model. So it's very simple, clean, and very useful for building our macroeconomic models. It's not the most realistic assumption, but it helps us understand how expectations enter into consumption and output decisions. In later lessons, we'll talk about more adaptive and rational forms of expectations, which are more dynamic. If you found this helpful, don't forget to like the video and comment your questions and subscribe so you don't miss the upcoming lessons. I'll see you in the next one. Take care.